So in this module, we're going to kind of shift gears. We've been focusing a lot on organizing our code, creating functions, modules, using recursion, and now we're going to start talking a little bit more about structuring our data. So up until now, we've seen, I guess, 5 different data types. We've got ints, floats. We've seen strings, we've seen booleans, and we've seen none, although we haven't really talked about the none data type all that much. And today or in this module, we're gonna start um, looking at the first of 3 built-in non-scalar data types in Python that are significantly more advanced than the basic data types we've already seen. And the first one is tuples. Okay, so sequences first, before we get into this idea of a tuple. What is a sequence? We've seen um, strings as a sequence of characters, and for something to be called a sequence, really, we're talking about something as a collection of items with a specific order, right? Sequence implies order. A string literal can be written by a consecutive set of characters within quotes, right? We can use single or we can use double quotes, so it would be okay to just do this as well. Okay, and we know that we can take that string and we can put it into a variable, right? So we can say s equals, for example, and that would store my string, for example, into a variable called s. We've also seen ranges, right? So ranges were the second sort of sequence data type that we looked at, and we learned that when we started looking at for loops. And so in for loops, we used a range to be able to iterate over a sequence of numbers, right? And so we would call the range function with a start and an end and perhaps a step, and it would create a sequence of numbers. Incidentally, we also had the literal depiction of a range, and actually we'll see that this is really just a list. We'll cover lists in the next module, and that was just the sequence of numbers as well. The range function essentially generates a list. So one of the things that are common about the range and a string is that the individual members of the sequence were all of the same data type. So a string just has character data, it just has individual strings within it. And a range was just integers. Actually, we found it wasn't even numeric, it wasn't even real numbers. A range consists strictly of integer values. A tuple is a sort of a generalized version of a sequence. In a tuple, individual elements, individual things within the sequence can be of any type, and the types can be mixed. So you can have, for instance, a number and then a string and then another number, and that's perfectly fine. Everything that you know about strings and ranges, being able to index into them, being able to slice them, or take specific ranges within them, still works with tuples. So you already sort of know a little bit of how to work with tuples. But one thing that's new here is that the literal description, it doesn't use a bracket, and certainly doesn't use quotes, it uses an open and closed parentheses. So the literal version of a tuple, and there is no generating function like with a range. A tuple is just you have to write the literal value, or you can append to it, or you can modify. So you've got t0 equals our parentheses here, and that's just creating an empty tuple. T1, we can create a tuple with 3 elements, and again, the data type of each one of these elements does not need to be the same. Right, so that's the literal depiction of a tuple. And I have to correct myself. I just said that you can change tuples. One of the things about a tuple that is similar in a way to a string is that they are immutable. They do not change. Tuples are sort of constants as you create them. And we'll keep that in mind because that's something that'll be different with lists. So their tuples can be combined. So I said that a tuple can have any data type as one of its elements, then that includes actually another tuple. So if we look at T1 with an integer, a string, and another integer as its elements, we can create another tuple T2, which consists of T1 as its first element, followed by a float. And so if we were to print out T2, it's kind of important to see how this is working. We've got a list, and I colored T2. Its parentheses are in blue. It encompasses two elements. Right, one is this initial T1. Right, T1 has been placed inside that tuple as its first element, and the second one, 3.25. The three elements in T1 are still, of course, there. The plus operator allows us to actually concatenate two lists, or two tuples. Right? So we can take a tuple 1 and a tuple 2 and concatenate them, and now we've got T1. And notice there is no individual open and closed parentheses. This is actually the first, the second, the third element, and now the result also has what was in T2. Now this is a little bit of a tricky example in that T1 had already been placed into T2. So in fact, we have 1, 2, 3, 4, 5 elements in the result of T1 plus T2. So continuing on with the idea that tuples work quite similarly to strings and ranges, we can index into them. So we can access individual elements of a tuple using the bracket notation. So that's a pretty familiar notation from the string examples. So here I've got T2 again, that's from the last slide. 1, 2, 3. The fourth element, right, which would be index 3 because this is index 0, 1, 2, 3. The fourth element can be printed out just by using bracket 3. If we want to take the result of T1 plus T2, again, this entire tuple, and we want to create a new tuple consisting of element 2 through 5, we can do that. So remember index 0, index 1, index 2. We're starting there. We're covering 4 and 5. Excuse me, I'm sorry, 2, 3, and index 4. So one of the nice things about tuples is that it offers a very convenient way for us to hold multiple items at the same time. So I mentioned with functions a while back that functions can only return one value. And that doesn't change with tuples, but the thing is that a function can return a tuple. And by returning a tuple, you're essentially returning a set or a sequence of values. So this is one pretty convenient example where I've got a function called find divisors, and I'm trying to return all of the numbers that divide evenly into n1 and n2. And so certainly we really have no idea how many different numbers there might be. Obviously we're going to have one. One's going to divide evenly into each one of these. But other than that, we can have any number of common divisors. So it's not for trying to find the greatest common divisor, just a divisor, a common divisor. So I'm looping through, but before I loop through, I'm going to create an empty tuple. And so now as I go through this, I'm going through each number up to and including actually the smallest between n1 and n2. And for each one of those numbers, I'm going to see whether it divides evenly into n1 or n2, and if and n2, I'm sorry. And if I find that it does, that means it's a common divisor. Right? And so this code is worth kind of spending a little time here. First of all, we are actually taking the divisors, which initially starts out as empty, and I'm concatenating it with a new tuple consisting of only one value. And so this is a little strange. Why do I have I comma inside these parentheses? It would sort of be more intuitive that a tuple with I in it and only I in it would look something like this. It turns out though that this is illegal syntax because the parentheses in and of themselves actually don't do anything. And so what this really amounts to is I. Right? And I is just an integer. And you can't add an integer to a tuple. That's not the way it works. So the parentheses and the comma, right? The comma trailing that single element represents a tuple of size 1. And so that's kind of a weird quirk of Python. It's kind of unfortunate. Um, it's a mistake that a lot of people make. It's very easy to accidentally just type that instead. But if you want to create a tuple of one element, you must have that trailing comma. So what we're doing is we're taking divisors, a tuple, starts out as empty, but as we're cycling through this for loop, it could have any number of values in it. And we're concatenating another tuple with one value in it. And that creates a new tuple, and we're assigning it to divisors. So over time, divisors keeps getting reassigned to a tuple consisting of each individual value that divides evenly into n1 and n2. And so this is a really kind of classic example of building up a set of return values and then returning it back. And we can figure out the length of a tuple just using the len command. So if I have a tuple t, I can just do length t. So whoever calls this find divisor function can get the return value. Maybe they assign it to a variable called t, and they can call length to figure out how many values are in that tuple. Another nice thing about tuples is that we can use them to assign several variables. Python supports sort of a unique usage of the assignment operator. If you're coming from other languages, this I think is one of the oddest things about Python. It supports the ability to assign multiple variables all at once. So on the left-hand side of an assignment operator, we are allowed to have a comma-separated list of variables, as long as on the right-hand side we have a comma-separated list of expressions. And in this case, if I say x comma y equals 5 comma 6, the 5 will be assigned to x, and the 6 will be assigned to y, and it'll print out 5 and 6. So this is sort of a pretty traditional case of it. Another possibility, though, is to use tuples. So if I had a tuple and I knew that it was of length 3, and I wanted to sort of extract all of the elements into 3 independent variables, I can certainly do that by saying x comma y comma z equals this tuple. And at that point, the first element in t will be assigned here, the second element in t will be assigned here, third element in t will be assigned here. And when I print it, I'll get 1 and 3 because I skipped the y there. So that's a nice little useful little aspect of using tuples with assignment operators. So we're going to use tuples throughout the remainder of the course. The big takeaway here is that a tuple is an immutable, it's an unchangeable object that contains a sequence of other objects. The object types don't need to match within the tuple. And we can use it to collect answers. We can use it in multiple assignments and a number of different possible use cases for it.